Hi everyone, welcome to our YouTube channel. This is the Skyline Institute. Thank you so much for joining us for our first lecture of the SkyMath Series. For more videos, please follow us on Instagram at Skyline Institute GH and on Facebook and YouTube at Skyline Institute Ghana. Be sure to also subscribe to our YouTube channel and give this video a thumbs up. You can also send in your comments, questions, and feedback in the comment section below. You can let us know other topics you'll be interested in learning. So today's lecture is the part 1 of a 2-part series on sets. So first of all, what is a set? A set can be described as a well-defined collection of objects, names, numbers, or ideas. The term well-defined simply means that you can readily tell whether or not something is part of the set. So for example, the set S is equal to even numbers less than 10. That means that the set S is equal to the numbers 2, 4, 6, and 8. There are some useful definitions that you need to know under this topic. The first is elements. So the elements of a set simply refers to the members of a set. This is what makes up the set. Then we have the finite set. A finite set is a set whose last member can be found. That is, the set has an end. An example will be the set A is equal to the numbers 1, 2, and 3, or the set of colors in a rainbow. The set of colors in a rainbow is made up of the colors red, orange, yellow, green, blue, indigo, and violet. As such, it's an example of a finite set as it ends with the color violet. An infinite set, on the other hand, is a set whose last member cannot be found. An example is the set A over here, which is made up of the numbers 1, 2, 3, dot, dot, dot. The 3 dots at the end signify that the set goes on to infinity, and as such, its last member cannot be found. A second example will be the set B is equal to the set of all prime numbers. The set of all prime numbers is an example of an infinite set, as it goes on all the way to infinity. We will look at a definition of prime numbers later on in this lecture. Next, we have an empty set or a null set. As the name implies, an empty set is a set with no element, and it's denoted by the null symbol here. Next, we have a unit set. A unit set is a set with only one element. For example, the set A is equal to 3. A universal set is a set of all objects under discussion. We'll see this later on in an example. A subset is a set contained in another set. A union set of sets A and B is a combination of the two sets, and it is denoted by the union symbol. An example is the set A is equal to 1, 2, 3, and set B is equal to 2, 4, and 6. As such, A union B is equal to 1, 2, 3, 4, and 6. Please note that numbers that appear in more than one set are recorded only once in the union set. For example, the number 2. Here's a graphical depiction of a union set. An intersection set of sets A and B is a set of elements that are common in both sets, and it is denoted by the intersection symbol. For example, if we have the set A is equal to 1, 2, and 3, and set B is equal to 2, 4, and 6, A intersection B is equal to the number 2, since 2 is the only number that is common in both set A and set B. Here's a graphical depiction of an intersection set. Here we can see that the intersection is the shaded area in blue. A complement of a set. If A is a subset of a universal set, then the complement of A, denoted by A prime, is the set of elements which belong to the universal set but do not belong to the set A. An example is shown in the diagram below. In this example, we have the universal set is equal to all numbers ranging from 1 to 10, and the set A is equal to the numbers 1, 2, 7, 8, and 9. As such, the complement of set A, or A prime, is equal to the numbers 3, 4, 5, 6, and 10, since they are part of the universal set but do not belong to set A. A prime here is going to be the shaded area here in blue. An equal set. So equal sets are sets that contain the same elements. For example, the set A is equal to the numbers 1, 2, and 3, and the set B is equal to the numbers 2, 1, and 3. As such, set A is equal to set B since they contain exactly the same elements. Equivalent sets. So equivalent sets are sets that contain the same number of elements. Please do well to know the difference between the equal set and the equivalent set. With the equivalent set, they contain the same number of elements. So an example here is if we have the set A is equal to 1, 2, 3, 4, and set B is equal to A, B, C, D. Both set A and set B contain 4 elements in total, and as such, they are equivalent. We can then say that set A is equivalent to set B and is denoted by this sign here. Whole numbers. So whole numbers are numbers beginning from 0, 1, 2, 3, all the way to infinity. Natural or counting numbers are numbers beginning from 1, 2, 3, all the way to infinity. Note that the difference between whole numbers and natural or counting numbers is that whole numbers include the number 0. An integer is a positive or a negative whole number. For example, the numbers ranging from negative infinity all the way to infinity is an example of a set of integers. Even numbers. Even numbers are numbers that are divisible by 2. So for example, 2, 4, 6, 8, 10, 12, all the way to infinity. Then odd numbers are numbers that are not divisible by 2. So 3, 5, 7, 9, all the way to infinity. Next, we have a factor. So a factor is a number that can divide another number without a remainder. So for example, 2 and 3 are factors of 6. Since 6 is divisible by 2 and 6 is divisible by 3 without leaving any remainder, the other factors of 6 are the number 6 itself and 1. Multiples. A multiple is obtained by multiplying a number by an integer. So for example, the multiples of 3 are 3, 6, 9, and 12, all the way to infinity. Here we can see that when you multiply 3 by the positive integers 1 to 6, you get the multiples of 3. A prime number. A prime number is a number with only 2 factors, 1 and itself. And the examples are 2, 3, 5, 7, all the way to infinity. Note that the number 2 is the only prime number, which is an even number. So here are a few questions for you to practice. You can try your hands at them and we'll discuss the answers shortly. So you can go ahead, pause the video and then solve the question and then come back and then look at the answers. So we hope you had fun solving those questions. Here are the answers to question 1 from the previous slide. So for I, we're asked to list the elements of the set A, which is equal to prime numbers less than 10. So for set A, we have the numbers 2, 3, 5, and 7. Then B is equal to even numbers between 0 and 20. So for the set B, we have the numbers 2, 4, 6, 8, 10, 12, 14, 16, and 18. For set C, we're asked to list all the numbers greater than 5. So for set C, we have the numbers 7, 9, 11, 13, 15, 17, 19, all the way to infinity. Set C is also an example of an infinite set, as it goes on all the way to infinity. Next, we have set D, which is equal to the factors of 20. The factors of 20 which make up set D are 1, 2, 4, 5, 10, and 20. Then we are asked to list the elements of the set A union D, which is equal to 1, 2, 3, 4, 5, 7, 10, and 20. And that's the combination of the set A and the set D. Next, we are asked to list the members of the set B intersection C. B intersection C is a null set, as we can see that the set B and the set C have no elements in common. So we have come to the end of today's lecture. Thank you so much for joining us today. Please make sure you subscribe to our YouTube channel to stay informed of our next videos. We hope to see you next time. Bye.